Okay, today we're talking about isosceles and equilateral triangles, and these are our content standards, GCO 10, GCO 12, and our mathematical practices. Previously, you've identified the isosceles and equilateral triangles. Today we're going to use properties of isosceles triangles and properties of equilateral triangles. 3 new vocabulary words: legs of an isosceles triangle, vertex angle, and base angles. Okay, recall that isosceles triangles have at least 2 congruent sides. The parts of an isosceles triangle have special names. The 2 congruent sides are called the legs. And the angle with the sides that are the legs is called the vertex angle. The side of the triangle opposite the vertex angle is called the base. The 2 angles formed by the base and the congruent sides are called the base angles. So these are the base angles, 1 and 2. AC and BC are the 2 congruent sides. C is the vertex. The isosceles triangle theorem: if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay. And the converse of the isosceles triangle theorem: if 2 angles of a triangle are congruent, then the side opposite those angles are congruent. Okay, so write the opposite. So if these base angles are congruent, their sides are congruent. And if these 2 sides are congruent, then those base angles are congruent. Name the 2 unmarked congruent angles. Angle BCA is opposite BA, right? This angle C is opposite BA. And angle A is opposite BC. So angle BCA is congruent to angle A. So angle BCA and angle A are the 2 unmarked congruent angles. Also, you see these congruent sides, the sides opposite, or the angles opposite those sides are congruent. Name 2 unmarked congruent segments. BC is opposite D, and BD is opposite BCD. So BC is congruent to BD. Or notice these base angles. So these base angles are congruent. This is the side opposite that's marked, so this side is the one that's not marked. So BC is congruent to BD. Time to check your progress, so pause the video for a moment and study the figure, and then give me your answer. Angle JMK is congruent to angle, JMK is congruent to angle JKM. Very good. Those are the larger base angles. How about this one? Pause for a moment and study it. Come back and check your answer. All right, so the segments, these are the 2 base angles, so PM is congruent to PK. That one was easier, wasn't it? And here's the proof of the isosceles triangle theorem. It's also in your textbook if you'd like to study it, or you can pause and read through each section for a moment. To prove the isosceles triangle theorem, you draw an auxiliary line, and we use the 2 triangles that are formed. Corollaries, there's of the equilateral triangle. If a triangle is equilateral, if and only if it is equiangular. So if all the angles are the same, then the sides are all the same measure. And by the same token, each angle of an equilateral triangle measures 60. Because if they all equal 180 and they're all the same, 180 divided by 3 would give you the 60. So find the missing measures. These 2 sides are the same. This one's 60. So by the isosceles triangle theorem, base angles P and R are congruent. So the measure of angle P is equal to the measure of angle R. So we're going to use the triangle sum theorem to write and solve an equation to find the measurement of angle R. Well, if all of them are together 180, and one of them 60, and we can write the measurement of angle R twice because P and R are equal, and substitute in and start solving. So the measurement of angle R is also 60. How about finding the measure PR? Find PR. Since all three angles measure 60, that means the triangle is equiangular. And because an equiangular triangle is also equilateral, we know that since PQ is 5, and then PR must be 5 by substitution. So 5 centimeters is our answer. Time to check your progress. So pause for a moment and study the example, then come back and check your answer. Okay, this is a lot like the example we just worked. These are the same measurement, so these base angles must be equal. So they must all be 60. Find the measurement of TS. But you found that answer pretty quickly, didn't you? Since all of these measures are 60, they all have the same measurement, so TS must be 3.5. You can use the properties of equilateral triangles and algebra to find missing values. You might take just a moment to draw this example because in a little bit this diagram is going to vanish, so it'll be easier if you have it with you. So the measurement of DFE is equal to 60 by definition of an equilateral. We're going to substitute in, because we're told that 4x minus 8 is the measurement of DFE. So x is 17. The triangle is equilateral, so all the sides are congruent. So we can substitute, set the two sides equal together so we can solve for y. So x is 17 and y is 4. Okay. I wonder what the answer to this one's going to be. Wonder if it's going to be B. Why don't you pause it for a moment, make sure you get that answer. Then come back and we'll go on. All right, now we're going to apply triangle congruence. Oh, let's take a look. Hexagon. Don't they just love spelling words? Hexagon. Notice that all the bases are the same, and it looks like we've got a bunch of isosceles triangles in here. So it's a regular polygon. ONG is equilateral. Oh, it's equilateral. So that means this is the same measure as these two sides. N is the midpoint of GE, and EX is parallel to OG. Oh, I didn't tell you. You might want to draw that real quick. Pause it, so draw the figure, and then we'll come back. Okay, so now the proof. Statement and reasons. We list our given. We're told that it's ONG is equilateral, so all those sides are congruent. We're given that N is the midpoint of GE, so by the midpoint theorem, NG is congruent to NE. We're given that these two segments are parallel, so because of the alternate exterior angles theorem, we've got two angles congruent, so we've got side angle side. Then the definition of equilateral, all three sides are congruent, so by CPCTC and substitution, we've got the definition of an equilateral triangle. Triangle E and X is equilateral. Okay, so time for you to check your progress. Why don't you study this figure for just a little bit? It looks just like the other one, so if you drew it before, you're doing pretty good. And then in a moment, we'll go on to the next step. All right, what is the missing reason? Oh, well, it looks to me like we've got, this one's being funny, isn't it, giving us the answer? CPCTC, corresponding parts of congruent triangles are congruent. All right, looks like you're ready to start your assignment.